FLAC stands for Free Lossless Audio Codec. It's an audio format similar to MP3 but lossless. This means audio is compressed in FLAC without any loss in quality. It is generally used when we have to encode audio without compromising on the quality. FLAC is an open source codec, and codec means software or hardware that compresses or decompresses digital audio. And FLAC is not only open source, but it's also free to use. One thing I would highly recommend if you are trying to use FLAC is to use ARMv7. This video is all about optimizing FLAC because we already know that FLAC enables you to have superior quality without losing any audio of your choice, but at the same time there is still some room to even optimize the FLAC. There are two techniques I'm going to discuss for optimizing FLAC, but one thing before I go into it is to highly suggest that you use ARMv7 embedded platform for the FLAC. ARMv7 is a version of ARM processor or architecture. It is used in a wide range of devices including smartphones, tablets, and embedded systems. So once you are using ARMv7 architecture for your FLAC, you already have won half the battle. Now, the question arises, why exactly do we need to even optimize FLAC further? Optimizing FLAC in terms of its performance will make it faster. That way it will encode, decode, or in other words, decompress the audio faster. Suppose you are using one of your favorite music streaming apps and suddenly you encounter glitches or pauses in your listening experience. How would you react to the above? A poor user experience will cause this app to lose users to the competition. There can be many reasons for that glitch to happen, possibly a network problem, a server problem, or maybe the audio codec. The app's audio codec may not be fast enough for your device to deliver the music without any glitches. That's the reason we need fast codecs. It's a critical component within our control. FLAC is a widely used audio codec because of its lossless nature. Now, there are two optimization techniques you can use to optimize the FLAC. One is we call a C optimization technique, and the other one is ARM assembly optimization. FLAC source code is written in C language. So we can arrange the FLAC source code or write it in a certain way that will execute it faster. As FLAC source code is written in C, so you need to be a C programmer. Now, this is highly specialized thing. So if you are really well versed in C, only then you should be able to optimize the FLAC with the help of C. Another one is through assembly optimization. Again, if you're really watching this video and are interested in FLAC optimization, then I'm sure that you already are aware of the assembly optimization because assembly optimization gives the best results in this case. Usually, a general codec uses complex algorithms that involve many complex mathematical operations, and loops are one of them. So, for example, if you are doing C optimization, you need to be well versed in the loop optimization because loops are one of the parts where a codec generally spends more time. So, this is a low hanging fruit. The more you optimize the loop, the better your quality will be and the response time will be. Just to give you an idea about this looping thing in C, loops have three parts: initialization, condition checking, and increment. In the loop, every time we have to test for condition to exit and increment the counter. So the more you optimize this loop and these three phases of the loop where you do the initialization and condition checking, especially the condition checking, the more faster your codec will be. Now, for the ARM architecture or the assembly operation which I was discussing, you need to optimize your memory. That will give you the best bang for the buck. Memory access can significantly impact performance in C since multiple processor cycles are consumed from memory accesses. ARM cannot operate on data stored in memory. It needs to be transferred to the register bank first. This highlights the need to streamline the flow of data to be the ARM CPU for processing. So we can utilize cache memory, which is much faster than main memory, to help minimize this performance penalty. Now, for the assembly optimization in particular, as you already have seen that we can leverage the processor feature to the full extent. For example, if we have a neon coprocessor, floating point unit, and EDSP unit in ARMv7, which accelerate mathematical operation, then we should be using it. Also remember that compilers convert C code to the assembly code, but may not always generate efficient code for certain functions. Writing these functions directly in assembly can lead to further optimization. But if you don't know assembly, then there is no point in doing it because it is again a very highly specialized field. So I hope that this helps you out uh, in optimizing the flag if you're looking to do so. Um, I know it's a bit hard, but once you do it, it's very satisfying. If you have any feedback or any further suggestions, please put them in the comment section. Thank you.